Okay, so the purpose of this video is to show the solutions to all the problems that I had you guys do at home, page 224 to 225. And like I said, you don't need to write anything down other than the answers. Okay, so let's go ahead and get started. Number one, quotient of two polynomial expressions is a rational expression. That would be true. Okay, graph y equals 1 over x. Well, we know how that looks. Y equals 1 over x looks just like this. That's in the notes as well. And then 2 times this function here. So y equals x squared, we're going to shift it to the left 1 unit and down 3. And then this little 2 out here, that just stretches it out just a little bit, makes it a little bit thinner. Okay, so we can do this. Left 1 unit. So let's start with our initial graph y equals x squared. Okay, if we go left 1 unit, then we have the graph looking like this. Okay, it's 1 unit. And then down 3. So the vertex of our parabola is going to go down 1, 2, 3, and end up down there. And yeah, that y equals x squared is that wide, so then y equals, let me do it in a different color, 2 times, yeah, so that's it right there. 2 times x plus 1 squared minus 3. So that's just a little reminder of how you're supposed to use transformations to draw the graph of a function where you actually know the parent function. Okay, so number 5, domain of every rational function is the set of all real numbers. And you should have said no way, because that's when we have restrictions on our domain, is when we're dealing with rational functions. Okay, so if as x is approaching negative infinity way out that way or way out this way, the values of r approach some fixed number L, then y equals L is a horizontal asymptote. So that's good. We can put ha in there. Okay. Number 7, if x is approaching some real number C, the values of r approaching either positive or negative infinity, then the line C, x equals C is a vertical asymptote, a va, of the graph of r. For a rational function, if the degree of the numerator less than the degree of the denominator, then r is proper. So we talked about that, so it gives us a name for it. Denominator is greater than. Okay. Graph of a rational function may intersect a horizontal asymptote. That's true. You can intersect a horizontal asymptote, but you may not intersect a vertical asymptote. That would be crossing the line there. So if a rational function is proper, then well, then we know that y equals 0 is a horizontal asymptote. And true or false, if the degree of the numerator equals the degree of the denominator, then the ratio of the leading coefficients gives rise to the ha, and that would be true. Okay? Alright, let's go on to the next page. So for number 14, we can see, we already did that one. 3 plus x is equal to 0, so x equals, let's see, domain. 3 plus x does not equal 0, x cannot equal negative 3. Okay, so there's our domain for number 14. Number 20, we can see that we have x squared plus 1, which will always be positive, multiplied by x squared minus 1, which is x plus 1 times x minus 1. So therefore, number 20 would be x, all values of x, such that x cannot equal plus or minus 1. Okay. You can see I'm not too picky about how you express your answers. I'm fine with either one of those methods. All right. So let's look at number 22. We can see that number 22 is always going to be positive denominator, so never will the denominator be equal to 0. So therefore, we say that the domain is all real numbers for number 22. And I just want you to know this all real number symbol, that's 2 vertical line segments and then the big old capital R. So I had some misunderstanding about that. Alright, so let's factor for number 24. Let's go ahead and factor our denominator. So we have x plus 2 times x plus 2. Alright, and then we have x plus 2 times x minus 2. That's kind of interesting, because we have this, even though we cancel the factor x plus 2, we still have another one. Well, guess what? That means that x cannot equal negative 2. Okay. It doesn't matter if we can cancel it. I don't know why I did that. I guess I was thinking I was going to be trying to find the vertical asymptotes, but yeah, Shouldn't cancel a factor and then do the domain. Just do the domain without canceling any factors. Okay, but I got, don't worry about that because we already have that x plus 2 here. Okay, let's try the pause the video here and we'll move on to the next slide. Okay, so for 26 and 30, we're just trying to start with 26, domain and range. Domain would be all real numbers x such that, what did I put a 1 there? X such that x cannot equal, what does that say there? What is that? -1. Alright, and the range would be all real numbers y such that y has to be greater than 0. Okay, there's our range. And then the intercept, well, I mean, we could just see the range. The y values go down to 0 and go up to positive infinity. The x values include every x value except for this vertical asymptote, which is at x equals -1. Okay. The intercepts, we can clearly see that 2 is a y-intercept and we have no x-intercepts. We have the line y equals 0, and that y equals 0 is our horizontal asymptote. Okay, and the vertical asymptote would be the x equals -1. Okay, and then we're, again, like I said, we're not going to be finding oblique asymptotes. Okay, so let's take a look over here. We've got domain and range. Domain is all real numbers except for -1 and +1. I'm not going to write it out. I'll let you do that. Okay, and then the range, though, you might be maybe a little bit confused. I guess I got to do it. So domain is x cannot equal -1 or +1. So there's the domain. Okay, the range, though, you can see if you were to look at the graph from this perspective, anywhere from the left, you don't see any breaks in the graph. In fact, there are no breaks in the graph. The range is all real numbers because we don't have any openings. Y can take on all values from -infinity all the way to positive infinity. So we say the range is all real numbers. Okay, so that takes care of the first part. Important to keep reviewing those concepts. So where do we have intercepts? Well, we see we only have one of each, but we do have one x-intercept and a y-intercept. X-intercept is 0, y-intercept is 0. Okay, so that takes care of those. Now, again, notice that we're not crossing any vertical tangent, vertical asymptotes, but we are crossing the horizontal asymptote. That's okay to cross a horizontal asymptote. Okay, what else do we need? We've got, we had intercepts, 0 and 0, but then we had the need to find our horizontal asymptotes. So the horizontal asymptote here would be, the ha would be y equals 0. Okay, same with this one as well. So I might as well use that. And then the va would be your x equals -1 and x equals +1. And those are the vertical asymptotes. That's it. Just by looking at the graph, we have no work to do. It's just looking at it and answering the questions about the graph. Okay, time back in, last few problems. 3 over x, that just gets the little kind of, I guess this part right here is what I'm trying to say here. It's a little further away. Like if you were to look at 1 over x, it would come in like this. Okay, 3 over x gets further away. Like 5 over x would be out there. Okay, so 3 over x is just going to look exactly like 1 over x, just a little bit further away from the origin. Okay, so that's that one. And then over here, number 40, we know that 1 over x, again, looks like this. 1 over x plus 1 would be, we would scoot the graph over 1 unit. So let's go ahead and draw the vertical asymptote. So we would scoot the graph of 1 over x over to the left 1 unit. Okay, but then we have to use that minus sign out here. What does that do? That flips it over. It's an outside, so it flips it over the horizontal axis. And so now the graph would look like this, a mirror image of the blue graph. So let's go ahead and let's actually do this. So the green graph then is a mirror image of the blue graph. Okay, and that's just negative 1 over x plus 1. But then we have this 2 here. What is that? How does that affect the graph? Well, the way that affects the graph is That's a plus 2 on the outside, so we're going to go up 2 units. Now, by the way, going up 2 units, this was a horizontal asymptote, the x-axis. But now it's going to be a horizontal asymptote up here. Horizontal asymptote of y is equal to 2. So we're going to take the graph that we see here, and we're going to draw it 2 units up. That's all. Just draw it 2 units up, and you're good to go. Okay, that's probably the hardest one that you'll do. Let's look at 44. We're asking for vertical. So ha and va. We need to find the ha and the va. Well, the va is x equals 6 because x minus 6 equals 0, and when x equals 6. And the ha for this one would be 3. Y equals 3. Make sure you put an equation for that. Never, ever, ever just say 3 like I just did. And never just say 6 for the vertical asymptote, because if you just say 6 and 3, well, how do we know which ones you're talking about? Okay, but horizontal and vertical asymptotes always come in the form of an equation. Okay, so let's do this. Let's take a look at this function right up here on number 50. Okay, so for number 50, we've got x squared plus 6x plus 5. Well, I know I can factor that. I'm going to have to factor because I don't know if we have any vertical asymptotes or not. Okay, so x plus 5 times x plus 1. And then here's your clue. Probably you're going to have an x plus 5 down here. Okay, and then you're going to have a 2x, and then you're going to have a 1. Does that do it? So factoring our denominator, we've got x and 10. No, that's not going to work. Okay, 1x and 10x gives us 11x, so yeah, that's not going to work. Okay, let's try it again. I was going to say, usually the denominator gets one of the factors in the numerator, so let's try the x plus 1, and what are left with 2x plus 5, and that'll do it, because the 5x and 2x is 7x, and then plus 5. But notice here that we get to cancel that factor. Canceling the factor, all that does for us is it tells us that x equaling negative 1 is not a vertical asymptote, it's a hole in the graph. However, if 2x plus 5 is equal to 0, then 2x equals negative 5, and x is equal to negative 5 halves. Negative 5 over 2. Okay, well that's vertical asymptote. Because with the function, well, I can't even tell what that is, f of x, with the function f of x equaling this, oh shoot, I'm on the wrong one. Let's try it again. There we go. It is f of x still. So f of x equaling this kind of big ugly function here, well, we can't determine yet whether we have a vertical asymptote or not unless we factor both numerator and denominator, get it f of x in its simplest form, and then we can figure out what the vertical asymptote is. Alright, so we have that vertical asymptote, that's great, but what's the horizontal asymptote? Well, the horizontal asymptote for number 50, noticing that the coefficients, noticing the degrees of the polynomials both on top and bottom are the same, so we just peel off the coefficients. 1 divided by 2, and that would be our horizontal asymptote. Not that, but y equaling that value. 1 over 2 is our horizontal asymptote. Okay, so I think we have one more, and it's this guy right here, x squared minus 16. So let's see what we've got. I'm going to do the work over here for number 54. We've got x to the 4th minus 16, and then we have over x squared. I'm going to make sure I write this down. I can't see the whole screen. X squared minus 2x. Okay. So in factoring the numerator, I know that I've got x to the 2nd, so x squared plus 4, and x squared minus 4. And x squared minus 4 is, as we say, difference of squares. And we have x plus 2 times x minus 2, and then that gets divided by x times the quantity x minus 2. Alright, well that helps. We've got 1 canceling, so what are we being asked for? We're being asked for the vertical asymptotes, and the vertical asymptote for this guy would be x is equal to what? X equals 0. Okay, and then actually literally falling asleep as I'm talking about this stuff, so I'm almost done. That's vertical asymptote. HA, so for ha, for number 54, we can see that the numerator has a greater degree than the denominator, and we've got none. We have no ha's. And is that it? I think that's it. I hope that helped. I will see you on Monday. Have a great weekend.